The stars were screaming, not in sound. Space permits no such luxury, but in data, in wavelengths, in the desperate electronic whispers caught by 66 radio dishes scattered across Chile's Atacama desert like ancient stone circles built to commune with gods. On the night of October 13, 2024, those dishes heard something that should not exist. Dr. Elena Vasquez pulled her jacket tighter against the desert cold, her breath forming clouds in the thin air 16,000 feet above sea level. The Atacama Large Millimeter Array stretched before her, a technological constellation more precise than any astrolabe ever crafted by medieval astronomers. These dishes had listened to the universe's secrets for over a decade. They had heard the birth cries of stars, the death rattles of galaxies, the whispered conversations between cosmic giants separated by billions of years. But tonight, they heard something else, something moving, something impossible. The discovery began as they always do, with numbers that refused to behave. Astronomer James Chen had been running routine calibrations when the detection algorithm flagged an anomaly, a speck of light, barely brighter than background noise, moving against the fixed tapestry of stars. Nothing unusual there. The sky is full of moving objects, satellites, asteroids, space debris from humanity's brief but enthusiastic fumbling in the cosmic dark. But this speck was different. Before we go further, I need you to understand something. What you're about to hear isn't just another space story. This isn't science fiction dressed up as history. This is a chronicle of the moment when humanity realized we might not be alone in watching the Watchers. Give this video a like, subscribe to this channel now. In 2017, humanity had been stunned by Oumuamua, a cigar-shaped enigma that tumbled through our solar system faster than any asteroid should move. Scientists scrambled to explain its strange acceleration, its unusual reflectivity, its refusal to behave like anything they had ever seen. Some whispered about solar sails, artificial origins, probes from distant stars. Others insisted on natural explanations, even as those explanations grew increasingly strained. 2 years later, Comet Borisov arrived. This one looked more familiar, a proper comet with a tail, outgassing water and carbon monoxide as it warmed. Yet even Borisov carried mysteries. Its chemistry didn't quite match anything in our solar system. Its nucleus remained hidden beneath veils of gas and dust. It was natural, they said. Probably. Now came the third. But context matters here, and context is what makes this discovery so disturbing. For centuries, astronomers had predicted that interstellar objects should be rare, perhaps one detection per century if we were lucky. The mathematics of galactic dynamics suggested that most debris expelled from other star systems would disperse into the void, invisible to our instruments, passing unseen through the emptiness between stars. 3 detections in 7 years shattered those predictions. Chen stared at his screen, watching the object's position update in real time. The coordinates shifted with mechanical precision, marking a path that had been calculated billions of miles away, billions of years ago. This visitor had been traveling since Earth's continents took their current shape, since the first human looked up at stars and wondered what they were. The ancient Babylonians called comets hairy stars and feared them as omens of catastrophe. When Halley's Comet appeared in 1066, the English saw it as a harbinger of Norman conquest. They weren't wrong. William the Conqueror landed that same year, and Harold Godwinson died with an arrow in his eye at Hastings. The Bayeux Tapestry immortalized that comet, stitched in wool and fear, a reminder that the sky sometimes announces the fall of kingdoms. But those were predictable visitors, members of our solar family returning on schedule. This new arrival was different. It came from somewhere else entirely. The preliminary orbital analysis arrived at 3:47 a.m. local time. Chen's hands trembled as he opened the file, coffee growing cold at his elbow. The numbers struck him like physical blows. Hyperbolic excess velocity, 62.3 kilometers per second. That speed was wrong. Catastrophically, impossibly wrong. Objects ejected from other star systems through normal gravitational encounters rarely exceed 20 kilometers per second. The fastest natural visitors should move at perhaps 30 or 35 kilometers per second at most. This thing was moving twice that fast, carrying energy that suggested violent origins, or Chen pushed the thought away, something else entirely. But the speed was just the beginning. As more observatories turned their attention to the visitor, as spectrographs dissected its light and radio telescopes listened for any whisper of artificial origin, a pattern emerged. Each measurement deepened the mystery. Each answer spawned 3 new questions. The object's chemistry defied expectations. Its survival across interstellar distances challenged physics. Its trajectory suggested origins in the thick disk. A stellar population formed when the galaxy was young and violent, when the universe itself was barely a quarter of its current age. Dr. Sarah Mitchell from the Jet Propulsion Laboratory captured the growing unease in her initial report. We are observing an object that appears to violate multiple assumptions about interstellar debris. Its characteristics cluster at the extreme end of every measured parameter. In isolation, each anomaly might be explainable. Together, they suggest either a profound gap in our understanding of galactic dynamics, or she never finished that sentence in the official report. The implications hung in the air like smoke from a distant fire. For the first time in human history, we possessed instruments sensitive enough to detect interstellar visitors regularly, and the first 3 we found all carried signatures that pushed against the boundaries of natural explanation. Medieval chroniclers wrote of dragons in the sky during times of great change. They described serpents of light that appeared before plagues, invasions, the death of kings. Modern minds dismiss such accounts as superstition, but the core truth remains. Humans have always understood that strange things in the heavens herald transformation. The ancient Chinese maintained careful records of guest stars, supernovae and comets that appeared without warning in supposedly fixed constellations. They believed the mandate of heaven could be read in such signs. When guest stars appeared, dynasties fell. When dragons danced across the sky, the world changed. On October 14, 2024, as news of the 3rd interstellar visitor spread through astronomical networks, that same primitive recognition stirred in human minds. Something was different about this one. Something that made seasoned scientists double-check their calculations and look over their shoulders. The object received the designation 3I ATS, the 3rd confirmed interstellar visitor detected by the Asteroid Terrestrial Impact Last Alert System, a clinical name for something that might redefine humanity's place in the cosmos. But names have power, and in choosing to call it Atlas, the astronomical community perhaps revealed more than they intended. In Greek mythology, Atlas was the Titan condemned to hold up the heavens, bearing the weight of the sky on his shoulders for eternity. He was a watcher, a guardian, a being whose very existence maintained the cosmic order. The question that kept astronomers awake that first night was simple and terrifying. What if this Atlas was also watching? What if it too bore the weight of some cosmic responsibility we could not yet comprehend? As October's darkness deepened over the Atacama Desert, radio dishes continued their vigil. They listened for any whisper that might betray artificial origin, any signal that might transform this mystery from astronomical curiosity to first contact. The silence was absolute. No transmissions, no coherent signals, nothing but the natural emissions of gas and dust warming in sunlight. But silence, as any hunter knows, can be the loudest sound of all. In the depths of that Chilean night, as instruments around the world turned their attention to the visitor, a different kind of recognition began to take hold. Not the excitement of discovery, but the chill understanding that some discoveries change everything, that some questions, once asked, cannot be unasked. 3 visitors in 7 years, each one strange, each one pushing boundaries, each one arriving just as humanity developed the capability to detect them. The pattern was troubling enough to make statisticians nervous and philosophers sleepless. But the pattern was just the beginning. Because 3IA Atlas was moving faster than anything they had ever seen, carrying mysteries that would challenge every assumption about the nature of interstellar space. And as its hyperbolic trajectory carried it deeper into our solar system, as spectroscopes began to dissect its light and reveal its impossible chemistry, one question began to haunt every observatory on Earth. What if coincidence was the wrong word entirely? Speed kills. This fundamental truth has shaped every predator, every prey, every survival story since life first learned to move. The cheetah's burst, the falcon's dive, the bullet's flight. Velocity determines who lives and who dies, who escapes and who is caught. In the cosmic arena, speed carries even greater significance. It separates the bound from the free, the captured from the escaped, the natural from the impossible. 3IA Atlas moved at 62.3 kilometers per second relative to the Sun. To grasp the violence of this velocity, consider every second this object traveled farther than most commercial aircraft fly in an entire minute. In 1 hour, it crossed 224,000 kilometers, more than half the distance from Earth to the Moon. In a single day, it swept through 5.4 million kilometers of space, leaving behind a trail of disturbed vacuum and scattered photons, like cosmic contrails marking its passage. This was not the lazy drift of interplanetary debris. This was not the predictable arc of a comet returning home. This was the trajectory of something fleeing or hunting. Dr. Marcus Webb stood before the whiteboard in Caltech's astronomy department, marker frozen in his hand. The equations he had written seemed to mock him with their implications. Around the conference table, 6 of the world's leading experts in orbital mechanics stared at the same numbers, each hoping someone else would find the error that would make this make sense. There was no error. "Run it again," whispered Dr. Jennifer Walsh from MIT's Haystack Radio Observatory. Her voice carried the weight of someone who had spent 30 years studying interstellar objects and had never seen anything like this. Webb input the parameters once more into the orbital simulation software. The program traced the object's path backward through time, projecting its journey through the galaxy. The result was always the same. 3IA Atlas had been traveling for billions of years, carrying kinetic energy that defied every model of natural ejection from stellar systems. The mythology of speed is written in human blood and ambition. Icarus flew too fast on wings of wax and feathers, drawn by the sun's promise until heat melted his artificial flight. The Greek messenger god Hermes wore winged sandals that carried him between worlds, bearing news that could topple kingdoms or save cities. In Norse legend, Sleipnir, Odin's 8-legged horse, could gallop across the sky and into other realms at speeds that bent reality itself. But these were stories of gods and heroes. Mortals who moved too fast paid the price. Physics demanded it. Yet here was 3IA Atlas, moving at velocities that should not exist in nature, carrying momentum accumulated across geological epochs. Its hyperbolic excess velocity, the speed remaining after escaping the sun's gravitational pull, exceeded anything scientists had previously observed. Oumuamua had entered our system at approximately 26 kilometers per second. Comet Borisov managed around 32. With each detection, the speeds increased. The pattern felt deliberate, as if each were more urgent than the last. Or as if each were more urgent than the last. The physics of such velocity painted disturbing pictures. Computer models of planetary formation suggested that typical ejection speeds during system formation rarely exceed 10 to 15 kilometers per second. To reach the speeds of 3IA Atlas required extraordinary circumstances. Close encounters with massive stars, gravitational slingshots around binary systems, or ejection during violent stellar encounters. Any explanation was possible in isolation, but the accumulating evidence suggested something beyond coincidence. Dr. Sarah Chen from the Harvard-Smithsonian Center for Astrophysics had spent her career studying the dynamics of interstellar space. The data from 3IA Atlas kept her awake for 72 consecutive hours, not from excitement, but from a growing sense of unease that she couldn't articulate. "It's not just fast," she told her colleague over coffee in the observatory break room. "It's optimally fast." The distinction mattered. Random ejection should produce a scatter of velocities, some high, some low, most clustered around average values. But 62.3 kilometers per second was not random, it was precise. Fast enough to escape any gravitational trap, swift enough to cross interstellar distances in reasonable time, yet not so extreme as to fragment under acceleration stresses. It was, in other words, exactly the speed a probe would choose. Ancient sailors understood the relationship between speed and survival. Viking longships were built for velocity as much as cargo capacity. Their shallow drafts and narrow beams allowed them to strike quickly and escape before defenders could organize defense. Speed was their shield, velocity their weapon. The great Polynesian navigators read the stars like maps, following celestial highways across thousands of miles of open ocean. They understood that timing was everything. Catch the right winds, ride the correct currents, and distant islands became accessible. Miss the window, and the Pacific became a grave. For these ancient voyagers, speed was not about reaching destinations quickly. It was about survival in hostile environments where delay meant death. 3I Atlas embodied this same philosophy. Its velocity guaranteed escape from our solar system's gravitational field. No human technology could intercept it. No trajectory change could capture it. It would pass through our neighborhood exactly once, gather whatever information its sensors required, then disappear forever into the cosmic dark. The escape velocity from our solar system at Atlas's current distance was approximately 12 kilometers per second. The object's speed of 62.3 kilometers per second provided 5 times the energy needed for departure. This excess was not waste, it was insurance. If 3I Atlas were a probe, its controllers had learned from history. They understood that reconnaissance requires not just stealth, but speed. The ability to observe without being observed, to gather intelligence without interference, to escape before the target realizes what has happened. The radio telescopes of the world had been listening to 3I Atlas since its discovery, scanning across every frequency band where artificial signals might hide. The search protocols were exhaustive. Narrow-band transmissions, spread spectrum communications, even modulated gravity waves. The most sensitive instruments on Earth strained to hear any whisper that might betray technological origin. They heard nothing. But silence, in the context of interstellar reconnaissance, was not empty. It was full of intention. During World War II, German U-boats prowled the Atlantic in radio silence, communicating only when absolutely necessary. Their survival depended on invisibility. A single transmission could trigger direction-finding equipment that would bring destroyers racing to their coordinates. The submarines that lived longest were those that spoke least. Soviet nuclear submarines during the Cold War elevated this philosophy to an art form. They operated in absolute acoustic silence, their crews speaking in whispers, their machinery dampened and isolated. To make noise was to die. To be detected was to lose the game before it began. If 3I Atlas were a probe designed for long-duration reconnaissance, silence would be its first and most critical feature. Any transmission, no matter how brief or encoded, could reveal its artificial nature. In a galaxy where the consequences of detection were unknown, discretion would be the highest priority. The mathematics of detection worked against observers, not targets. A probe needed only to avoid transmitting, but watchers like humanity had to scan every frequency, monitor every possible signal type, maintain constant vigilance across vast ranges of space and time. Advantage? Silence. The ancient Chinese military philosopher Sun Tzu wrote, "All warfare is based on deception. Hence, when able to fight, we must seem unable. When using our forces, we must seem inactive. When we are near, we must make the enemy believe we are far away. When far away, we must make him believe we are near." Applied to interstellar reconnaissance, this wisdom suggested that the most effective probe would be indistinguishable from natural phenomena. It would move like a comet, outgas like a comet, reflect light like a comet. Only its silence would distinguish it, and silence was the absence of evidence, not evidence of absence. The trajectory analysis revealed another troubling detail. Backtracking 3I Atlas's path through the galaxy placed its origin not in the galactic disk where most stars reside, but in the thick disk. An older stellar population formed when the Milky Way was young and chaotic. Stars in the thick disk averaged 10 to 12 billion years old. If 3I/Atlas truly originated there, it had been traveling since before Earth's formation, since before the sun ignited, since the galaxy itself was barely half its current age. The implications staggered the imagination. Any civilization capable of launching such a probe would have evolved when the universe was fundamentally different. Fewer heavy elements, more violent stellar formation, increased radiation levels. Yet somehow, intelligence had emerged in those harsh conditions and developed technology capable of crossing galactic distances. And now that technology had arrived in our solar system. Dr. Webb stared at the trajectory plot on his computer screen, watching the hyperbolic curve stretch backward through space and time. The object's path intersected with stellar positions from billions of years ago, when constellation patterns bore no resemblance to modern star charts. It's been traveling longer than complex life has existed on Earth, he said to the empty room. The words hung in the air like an accusation. If 3I/Atlas were natural debris, its journey represented the ultimate endurance test. Billions of years in the void, bombarded by cosmic rays, abraded by interstellar dust, exposed to temperature extremes that would shatter most materials. Yet it had arrived intact, still capable of outgassing, still active. If it were artificial, its journey represented something else entirely. Patience on a scale that human minds could barely comprehend. a mission launched by beings who understood that their probe would outlive their species, their star system, perhaps their entire galactic neighborhood. The technology required for such endurance challenged every assumption about the fragility of complex systems. Human spacecraft lasted decades at most. Our most durable constructions, pyramids, stone monuments, nuclear waste containers, were designed to survive thousands of years, perhaps tens of thousands of years. But billions of years? That suggested engineering principles so advanced, so alien to human experience, that the probe might as well be magic. The Vikings who sailed to Vinland carried stories of the world tree Yggdrasil, a cosmic ash that connected all the realms of existence. Its roots reached into the underworld while its branches held up the sky. It was eternal, unchanging, a constant presence that outlasted gods and giants alike. 3I/Atlas seemed to embody the same principle of endurance. It had traveled through the cosmic forest for eons, carrying within itself the memory of distant stars and ancient civilizations. It connected past to present, origin to destination, across scales of space and time that rendered human history insignificant. And it was still accelerating. The Doppler measurement showed subtle but consistent changes in the object's radial velocity. It was speeding up as it approached the Sun, following the predictions of orbital mechanics perfectly. But instruments also detected variations in its non-gravitational acceleration, tiny changes that could be explained by sublimating ices venting into space, but might indicate something else, something deliberate. The pattern was too subtle for certainty, but too consistent for dismissal. If the acceleration changes were random, caused by sublimating ices venting into space, they should be chaotic, unpredictable. Instead, they showed structure, as if someone or something were making tiny course corrections. Adjustments too small to be obvious, changes too minor to trigger alarms, modifications that looked natural but served purpose. As October gave way to November, as 3I/Atlas continued its swift passage through the inner solar system, the astronomical community found itself divided between natural explanations that felt inadequate and artificial hypotheses that seemed impossible. The object's speed remained its most troubling characteristic: too fast for comfort, too precise for accident, too silent for certainty. In the depths of space, 3I/Atlas raced onward, carrying its secrets at velocities that mocked human comprehension. Whether it was the product of cosmic violence or deliberate design, whether it carried intelligence or only ice, remained locked behind walls of silence that no telescope could penetrate. But the silence itself was speaking. And what it said was this: some things move too fast to be caught, too quietly to be heard, too distantly to be reached. They pass through human experience like ghosts, leaving behind only questions and the cold certainty that the universe holds more mysteries than answers. The speed of 3I/Atlas was not just velocity. It was message, warning, and promise combined. The message was clear: you are not alone. The warning was simple: you cannot catch us. The promise was the most disturbing of all: we will return. The elements don't lie. Or so we believed. For centuries, spectroscopy has been astronomy's most trusted witness, a forensic technique that reads the chemical fingerprints of distant worlds, stars, and wandering debris. Point a spectrograph at any celestial object, split its light into component wavelengths, and the elements reveal themselves like confession under interrogation. Hydrogen shows its presence at specific frequencies. Oxygen leaves unmistakable signatures. Carbon dioxide broadcasts its molecular structure across the void. The James Webb Space Telescope turned its golden eye toward 3I/Atlas on November 8, 2024, and saw something that should not exist. Dr. Angela Reyes stood in the Space Telescope Science Institute control room, watching data stream across multiple monitors. 23 years of studying cometary chemistry had prepared her for surprises. The universe loved to mock human assumptions. But what she saw in the spectroscopic readings from 3I/Atlas made her question whether she understood chemistry at all. Carbon dioxide dominated the spectrum, not just present, not merely abundant, but overwhelming every other volatile compound. The ratios were wrong, catastrophically wrong, defying every model of cometary formation developed over decades of careful observation. "Run the calibration again," she whispered to the technician beside her, though she knew the instruments were functioning perfectly. The James Webb Telescope had dissected the light of thousands of celestial objects. Its precision was legendary, its accuracy beyond question. But accuracy could be its own trap, because what it showed was a comet that behaved like no comet in our solar system, a visitor whose chemistry proclaimed it was formed under conditions alien to everything we knew about planetary birth. Medieval alchemists called it the Great Work, the attempt to understand the fundamental nature of matter, to discover the hidden relationships between elements, to unlock the secrets of transformation. They believed that they could master the dance of atoms, they could transmute base metals into gold, find the elixir of eternal life, bridge the gap between earthly matter and divine essence. Their laboratories were part workshop, part chapel. They mixed mercury with sulfur by moonlight, dissolved silver in acid while reciting prayers, heated compounds in furnaces while studying star charts. They understood that chemistry was more than mere reaction. It was the language by which the universe spoke its deepest truths. The spectral lines of 3I/Atlas spoke in that same ancient tongue, but the words it formed made no sense. In our solar system, comets carry the chemical signature of their birth environment. Water ice dominates most compositions, with carbon monoxide, methane, and carbon dioxide playing supporting roles. The ratios reflect the temperature gradient of the early solar nebula. Water froze first in the outer regions, followed by other compounds in order of their volatility. But 3I/Atlas inverted this pattern. Its spectra showed carbon dioxide concentrations 50 times higher than typical comets, while water remained strangely subdued. It was as if the object had formed in an environment where CO2 condensed preferentially, where the normal rules of ice formation were reversed or ignored. Dr. Reyes pulled up comparison spectra from other comets on her secondary monitor. Halley's Comet, Hale-Bopp, 67P Churyumov-Gerasimenko, all showed the expected water-dominated signatures. Even Comet Borisov, the previous interstellar visitor, had displayed chemistry that, while unusual, remained within acceptable parameters. 3I/Atlas existed outside those parameters entirely. "Where the hell did this thing form?" muttered Dr. James Hoffman from the University of Maryland. He had flown in specifically to observe the Webb data collection drawn by early reports of anomalous readings. Now he stood transfixed by spectra that seemed to mock his lifetime of research. The question haunted every astronomer who studied the data. If 3I/Atlas formed in a protoplanetary disk, that disk must have operated under radically different conditions than the cloud that birthed our solar system. Perhaps it originated around a star with different metallicity, different radiation output, different patterns of heating and cooling. But the thick disk origin suggested by the object's trajectory pointed to stellar populations formed when the galaxy was young, environments even more hostile to conventional planetary formation. The paradox deepened with each measurement. Ancient cultures understood that transformation could be deceptive. The Greek titan Proteus could assume any shape, appearing as lion, serpent, fire, or water to avoid prophecy. Only by holding him through all his changes could heroes force truth from his lips. The Hindu concept of Maya suggested that apparent reality was illusion, that surface appearances concealed deeper, more fundamental truths. In the laboratory of medieval Islamic alchemist Jabir ibn Hayyan, chemical transformations were seen as reflections of cosmic principles. Matter could appear as one thing while being another entirely. The art of chemistry was learning to see through disguise, to recognize the true nature hidden beneath deceptive surfaces. Dr. Reyes wondered if 3I/Atlas was practicing its own form of chemical alchemy. What if the CO2 dominance was not natural formation, but deliberate camouflage? What if something artificial was masquerading as cometary outgassing? The possibility seemed absurd until she examined the spectral details more closely. The carbon dioxide emissions showed structure, subtle variations in intensity and frequency that could indicate temperature gradients, pressure differentials, even controlled release patterns. Natural sublation should be chaotic, driven by solar heating and internal pressure, but these variations suggested organization, as if the gas release were managed rather than random. She pulled up historical data from other unusual objects, searching for precedent. In 1908, something exploded over Tunguska, Siberia, with the force of 1,000 Hiroshima bombs. The blast flattened 2,000 square kilometers of forest, but left no crater, no fragments, no clear evidence of what had caused it. Scientists eventually settled on a small asteroid or comet that disintegrated in the atmosphere. But what if they were wrong? What if Tunguska represented humanity's first encounter with technology disguised as natural phenomenon? The explosion occurred at the perfect altitude to maximize destruction while minimizing physical evidence. The lack of debris could indicate complete vaporization or successful concealment. The more Dr. Reyes studied 3I/Atlas, the more she understood why ancient peoples feared comets. These visitors carried the chemistry of other worlds, other environments, other possibilities. They arrived without warning, followed their own laws, departed on their own schedule. They were reminders that the universe operated by rules humans had not written. But chemistry was supposed to be universal. The same physical laws that governed reactions on Earth should apply everywhere. Hydrogen should behave like hydrogen, whether it resided in our Sun or Proxima Centauri. Carbon dioxide should form under similar conditions regardless of location, unless the chemistry itself was artificial. The thought struck her like lightning. What if the unusual ratios were not accidental, but intentional? What if 3I/Atlas carried its chemical signature as a form of identification, a marker that would distinguish it from natural comets to any observer sophisticated enough to read the message? She pulled up her secure communication terminal and began typing a message to her colleague at SETI, Dr. Michael Chen. If artificial intelligence were masquerading as a comet, it would need to outgas something. Why not choose compounds that served dual purpose, providing camouflage while broadcasting identity to those who understood the code? The ancient Greeks believed that fire was one of 4 fundamental elements, along with earth, air, and water. All matter was thought to be combinations of these basics in different proportions. But fire was special. It transformed, it purified, it revealed the true nature of things by burning away deception. The carbon dioxide streaming from 3I/Atlas was the product of fire, of combustion, of energy released through chemical bonds breaking and reforming. If this were natural sublimation, it represented ice laid down billions of years ago, finally returning to space. If it were artificial, it might represent fuel consumption, power generation, or waste heat from systems we could not detect. The spectroscopic analysis revealed another anomaly: trace compounds that defied easy identification. Complex hydrocarbons appeared and disappeared in the data, too faint for certainty, but too structured for dismissal. These could be contamination, instrumental artifacts, or the chemical signatures of processes unknown to terrestrial science. Dr. Hoffman ran his fingers through graying hair, studying the mysterious spectral lines. "You know what bothers me most?" he said to Dr. Reyes. "It's not what we're seeing, it's what we're not seeing." She knew what he meant. The spectra showed abundant CO2, traces of exotic compounds, hints of complex chemistry. But they showed almost no water, very little carbon monoxide, none of the simple molecules that should dominate any natural comet. As it was, 3I/Atlas had been scrubbed clean of ordinary chemistry, leaving only the unusual, the structured, the intentional. "It's like someone took a normal comet and replaced its contents," she replied. "Kept the shell, changed the interior." The comparison felt apt. Throughout history, intelligence had employed such substitution as strategy. The Trojan horse appeared to be a gift while concealing invasion. Confederate spies during the American Civil War used hollow books to carry secret messages. Modern steganography hides digital information within seemingly innocent image files. If a civilization wanted to send probes disguised as comets, they would need to master chemistry as camouflage. The probe would have to outgas like a comet, reflect light like a comet, follow orbital mechanics like a comet. But the specific chemistry could serve double duty, concealing artificial systems while providing fuel, coolant, or waste disposal. The CO2 dominance might not be evidence of unusual formation, but of unusual function. As evening descended over Baltimore, Dr. Reyes found herself alone in the control room, staring at spectra that seemed to stare back. The chemistry of 3I/ATLS had been formed somewhere, somehow, by processes that challenged every assumption about natural comet formation. Either their understanding of planetary chemistry was fundamentally flawed, or they were looking at the waste heat of a machine. Both possibilities were equally disturbing. The ancient alchemists dreamed of the philosopher's stone, a substance that could transform any material into gold, cure any disease, grant immortality to those who possessed it. They never found it, but their search laid the foundation for modern chemistry, physics, and medicine. Their great work became humanity's great work, the quest to understand the fundamental nature of reality through careful observation and experiment. Now, 3I/ATLS challenged that entire enterprise. Its chemistry followed rules written elsewhere, under conditions that might not exist in nature. It carried compounds that had no business existing together, ratios that made no sense, signatures that proclaimed either profound ignorance or deliberate deception. As midnight approached, as the data streams continued their relentless accumulation of impossible measurements, Dr. Reyes faced the alchemist's ancient dilemma. When the elements themselves began to lie, where could truth be found? The answer might be nowhere, or it might be in the lie itself, in the understanding that deception too was information, that artificial chemistry was still chemistry, that the elements could be made to lie, but only by intelligence sophisticated enough to understand their truth. Outside, the November night was clear and cold. Somewhere above, 3I/ATLS continued its swift passage toward the sun, venting its impossible chemistry into the void, leaving behind a trail of questions that no earthly laboratory could answer. The elements were speaking, but they were speaking in a language that Earth had never learned. Nothing should survive 10 billion years. Not organic matter exposed to cosmic radiation, not ice subjected to interstellar bombardment, not any complex structure small enough to be hurled from its birth system into the void between stars. The universe is not gentle with wanderers. It grinds them down, atom by atom, until nothing remains but scattered dust and fading memories. Yet, 3I ATLS had not only survived, it thrived. Dr. Elena Rodriguez sat in her office at the Planetary Science Institute, surrounded by computer models that refused to cooperate. Each simulation told the same impossible story. An object with Atlas's estimated size and composition should have been destroyed eons ago. The mathematics were unforgiving. The physics were clear. Survival on such scales was not merely improbable, it was forbidden. But prohibition meant nothing to something already here. The numbers painted a picture of systematic annihilation. Cosmic rays, those high-energy particles streaming through interstellar space, should have shattered any complex molecules within the first billion years of travel. Dust grains, sparse but persistent, would have sandblasted exposed surfaces at velocities measured in tens of kilometers per second. Temperature cycles between near absolute zero and solar heating should have fractured crystal structures, causing any coherent object to crumble into debris. 10 billion years of such treatment should leave nothing but atoms scattered across light years of space. Instead, 3I ATLS arrived intact, active, still capable of outgassing compounds complex enough to puzzle Earth's most sophisticated instruments. It defied destruction through mechanisms that challenged every model of interstellar survival. The ancient phoenix was humanity's attempt to understand impossible resurrection. In Egyptian mythology, this sacred bird lived for 500 years before building a nest of aromatic wood and spices. At the end of its life cycle, the phoenix would ignite its own funeral pyre, burning to ash in flames of its own creation. But from those ashes, a new phoenix would arise, young and strong, ready to begin the cycle again. The myth spoke to humanity's deepest understanding of mortality and renewal. Nothing lived forever, but some things found ways to transcend individual death through transformation, through renewal, through mechanisms that lay beyond ordinary comprehension. 3I Atlas embodied this principle on cosmic scales. It had somehow achieved what evolution, engineering, and natural law deemed impossible: persistence across geological time and an environment designed to destroy persistence. Dr. Rodriguez pulled up the Antikythera mechanism on her secondary monitor, a bronze device recovered from an ancient shipwreck near the Greek island of Antikythera. Dating to approximately 100 BCE, this complex clockwork computer could predict astronomical events with startling accuracy. Its existence had shocked archaeologists who thought such sophisticated gear trains were impossible for ancient civilizations. The device challenged every assumption about technological development. It suggested that human ingenuity could leap beyond expected capabilities, creating mechanisms that seemed anachronistic, impossible, too advanced for their time and place. What if 3I Atlas represented a similar leap, not in human technology, but in the engineering capabilities of some other civilization? What if its survival was not natural endurance, but artificial persistence, the product of design principles so advanced that they made the impossible routine? She began working through the survival scenarios systematically. Natural endurance required either exceptional composition or extraordinary luck. The object would need to be made of materials resistant to radiation damage, structured to minimize surface area exposed to abrasion, dense enough to resist fragmentation, but not so dense as to retain dangerous amounts of radioactive decay. Even under optimal conditions, the models predicted significant degradation after a few billion years. Complete survival for 10 billion years stretched probability beyond the breaking point. The alternative was more unsettling: engineered persistence. If 3I Atlas were artificial, its builders would have faced the same survival challenges that plagued natural objects. Radiation shielding would be essential. Self-repair mechanisms might be necessary. The ability to hibernate during the most dangerous portions of the journey could extend operational life dramatically. Such capabilities were not impossible in principle. Earth's most resilient organisms, tardigrades, certain bacteria, some fungal spores, could survive extreme radiation, temperature variations, and decades of dormancy. Evolution had already proven that life could persist under seemingly impossible conditions. But engineering such resilience into a machine, maintaining it across billions of years, ensuring functionality after eons of dormancy, that required technological sophistication that dwarfed humanity's current capabilities. The ancient Chinese philosopher Lao Tzu wrote about the paradox of durability. The softest things in the world overcome the hardest things in the world. Water carved through stone, not through force, but through persistence, through patient repetition across scales of time that made individual human lives insignificant. Perhaps 3I Atlas survived through similar principles, not through armor or shielding, but through adaptive response to damage. Not through resistance to change, but through controlled transformation that preserved essential functions while sacrificing non-critical systems. Dr. Rodriguez examined the observational data more closely. The object's activity levels seemed remarkably stable for something that had supposedly been dormant for billions of years. Most comets showed variable outgassing patterns as they approached the sun. Irregular jets, asymmetric heating, chaotic releases of trapped volatiles. Atlas displayed almost uniform activity, as if its internal systems were managing gas release with deliberate precision. The brightness curves told a similar story. Natural comets typically showed rotation-induced variations as different surfaces came into view. Atlas maintained steady brightness, suggesting either perfect spherical symmetry or active compensation for rotational effects. Both scenarios strained natural explanation.
The mythology of preservation runs deep in human culture. Egyptian mummification sought to preserve bodies for eternal life. Hindu and Buddhist traditions spoke of consciousness persisting through multiple incarnations across cosmic cycles. Greek philosophers debated whether the essence of a thing could survive, even when its physical form was destroyed. The ship of Theseus paradox captured the central question. If a vessel was repaired piece by piece during a long voyage, replacing every plank, every rope, every nail, was it still the same ship when it reached its destination? Did identity reside in materials or in patterns, in structure or in function? If 3I by Atlas had survived through continuous self-repair, replacing damaged components with identical copies across billions of years, was it still the same object that had been ejected from its origin system? Or had it become something else entirely? A pattern persisting through matter, a function outlasting form. The question was more than philosophical. If the object were indeed artificial, its builders might have solved the preservation problem through systematic replacement of worn components. Nanotechnology could enable such repair at the molecular level. Self-assembling systems could rebuild damage using raw materials harvested from interstellar space. Such capabilities would transform the economics of interstellar exploration. Instead of massive, expensive vehicles designed to last for single journeys, civilizations could deploy small, self-maintaining probes that could operate indefinitely. The galaxy could be filled with such wanderers, each one a mobile outpost of its parent civilization, each one capable of surviving long after its builders had gone extinct. Dr. Rodriguez's computer chimed with an incoming message from her colleague at MIT's Haystack Radio Observatory. Dr. Jennifer Walsh had been running statistical analyses on interstellar object detection rates, trying to understand why 3 visitors had appeared in such rapid succession after centuries of absence. The preliminary results were disturbing. If interstellar objects were randomly distributed throughout the galaxy, as traditional models suggested, the probability of detecting 3 in 7 years was less than 1 in 10,000. Either humanity was extraordinarily lucky, or the objects were not randomly distributed. The thick disk origin of 3I by Atlas complicated the statistics further. Objects from that ancient stellar population should be exceedingly rare in the solar neighborhood. The galactic dynamics that could deliver such an artifact to Earth required a chain of gravitational encounters spanning billions of years and thousands of light years. The odds against such delivery were astronomical. The odds against survival during such delivery were even worse. The odds against both occurring simultaneously for 3 different objects approached impossibility. Unless impossibility was the wrong framework entirely. Dr. Rodriguez found herself thinking about Voyager 1 and Voyager 2, humanity's most distant ambassadors. Launched in 1977, both probes had far exceeded their planned mission lifetimes. 47 years later, they continued transmitting data from interstellar space, their radioisotope thermoelectric generators still providing enough power for basic operations. But Voyager's longevity was measured in decades, not eons. Eventually, their power sources would decay, their instruments would fail, their signals would fade to nothing. They were marvels of engineering, but they were not immortal. What would it take to build something that could function for billions of years? What design principles could ensure survival across such scales? What technologies could maintain coherent operation while crossing distances that dwarfed the entire history of complex life on Earth? The answers required capabilities that bordered on magic. Self-repair mechanisms that could function indefinitely, power sources that could operate for geologic ages, materials that could resist degradation across cosmic time, information storage systems that could preserve critical data through eons of potential corruption. Any one of these capabilities would revolutionize human technology. Combined, they would enable exploration strategies that transform the galaxy from a collection of isolated systems into a connected network of intelligence. If such technology existed, if it were deployed by civilizations in the thick disk billions of years ago, then objects like 3I by Atlas might not be rare exceptions, but common artifacts. The galaxy could be filled with ancient probes, most of them dark and inactive, some still functional after eons of wandering. The survival paradox then became not a question of how one object could endure, but how many others might already have passed unnoticed. How many artificial artifacts had been dismissed as natural comets? How many probes had been cataloged as asteroids? How many visitors had crossed through the solar system before humanity developed the instruments to detect them? As December approached and 3I Atlas continued its steady progression toward perihelion, the survival question grew more urgent. Each day of continued activity provided more evidence that the object defied conventional explanations. Each measurement revealed new characteristics that strained natural models. The ancient Norse spoke of Gleipnir, a chain forged by dwarfs that was stronger than any iron yet appeared as light as silk. It bound the wolf Fenrir through paradox, something that seemed weak but proved unbreakable, something that appeared natural but was actually artificial, something that survived through principles that defied obvious explanation. Perhaps Three-Eye Atlas was bound by its own Gleipnir, held together not by materials or forces that humans understood, but by design principles that transcended ordinary physical limitations. Perhaps its survival was not accident but intention, not luck but engineering, not natural endurance but artificial persistence. The implications were staggering. If intelligence could build machines that lasted billions of years, then the galaxy was not the empty frontier that humanity imagined. It was an ancient realm, explored long ago, mapped by civilizations that had mastered time itself. And we were not explorers discovering new territories. We were late arrivals to a party that had been running for eons, trying to understand conversations that had begun before our species existed, attempting to decode messages written in languages of survival that we had never learned. Outside her office window, the Arizona night was cold and clear. Somewhere above, Three-Eye Atlas continued its impossible journey, carrying within itself the accumulated knowledge of survival strategies that challenged every assumption about what was possible in the universe. It had lasted 10 billion years. The question was no longer how it had survived. The question was what else might be out there, waiting in the dark, patient as stone, persistent as water, enduring as the stars themselves. And why, after eons of silence, they had chosen now to reveal themselves. Silence is the loudest sound in the universe. In the vacuum of space, no scream can be heard, no explosion echoes, no voice carries across the void. Yet the absence of sound becomes its own language, a vocabulary of emptiness that speaks volumes to those who know how to listen. For 50 years, humanity has pointed radio dishes toward the stars, straining to hear any whisper that might betray the presence of intelligence. We have listened with patience born of desperation, with hope born of loneliness, with instruments sensitive enough to detect a cell phone on Proxima Centauri. And we have heard nothing. But with Three-Eye Atlas, nothing had become something. The object's silence was too perfect, too complete, too deliberate to be accidental. It was the silence of a hunter in the forest, of a submarine beneath polar ice, of a watcher who understands that to speak is to reveal oneself to unknown predators. Dr. Michael Chen stood in the control room of the Arecibo Observatory's successor facility in Puerto Rico, watching data streams that showed exactly what he had expected and feared: absolute radio silence from the interstellar visitor. Bank after bank of receivers scanned every frequency band where artificial signals might hide. Narrowband transmissions, spread spectrum communications, burst patterns, modulated carriers. The search protocols were exhaustive. The results were always the same: nothing. But in SETI research, nothing was never really nothing. It was information of a different kind. The ancient Greeks told of Argus Panoptis, the hundred-eyed giant who could see in all directions simultaneously while never sleeping. Zeus appointed him guardian of Io, transforming her from woman to white heifer to hide her from her jealous wife Hera. Argus watched without blinking, without speaking, without revealing his thoughts. His power lay not in action but in observation, not in voice but in vision. When Hermes finally killed Argus through trickery and music, Hera placed his 100 eyes in the tail of the peacock, where they continue to watch even today. The myth understood a fundamental truth about surveillance. The most effective watchers are those who observe without being observed, who see without being seen, who gather intelligence without broadcasting their presence. If Three-Eye Atlas were a probe, its builders would have learned this lesson long ago.
Dr. Chen pulled up historical SETI data on his workstation, reviewing decades of failed searches. The famous "wow" signal, detected in 1977, had lasted 72 seconds and never repeated. Fast radio bursts appeared randomly from cosmic distances, their origins mysterious, but their patterns seemingly natural. Even the most optimistic SETI researchers had begun to wonder if intelligence in the galaxy was rarer than originally hoped. But what if intelligence wasn't rare, just careful? The dark forest hypothesis had emerged from Chinese science fiction, but gained serious consideration among astrobiologists. The concept was elegant in its paranoia. If the galaxy contained multiple civilizations, revealing oneself could be fatal. Any species advertising its presence risked attracting the attention of older, more powerful, potentially hostile neighbors. In such an environment, silence became survival strategy. The civilizations that lasted were those that learned to hide, to observe without being observed, to communicate only when necessary and only through channels that could not be intercepted by unwelcome listeners. The analogy to human warfare was exact. During World War II, German U-boats dominated the Atlantic through stealth and silence. They communicated with base through brief, encrypted transmissions that revealed little about their locations or intentions. American submarine doctrine during the Cold War elevated this principle to art. The best submarine was the one no other submarine could detect. If the galaxy operated under similar rules, then radio silence was not absence of intelligence, but evidence of its sophistication. Dr. Chen examined the technical specifications for Atlas observations. Radio telescopes in Australia, Europe, and North America had been monitoring the object since its discovery. The frequency coverage was comprehensive, from long-wave radio through microwave and into millimeter wavelengths. If the object were transmitting anything recognizable as artificial communication, the instruments would detect it. They detected natural emissions consistent with cometary activity, thermal radiation from warming ice, spectral lines from sublimating compounds, the electromagnetic signature of dust and gas interacting with solar wind. But no coherent signals, no structured patterns, no evidence of technology. The absence was so complete, it felt deliberate. Ancient Spartans mastered a different kind of silence. Their warriors spoke little, revealed less, used economy of language as psychological weapon. Laconic speech, named for their home region of Laconia, conveyed maximum meaning through minimum words. When Philip II of Macedon sent a message threatening, "If I invade Laconia, you will be destroyed forever," the Spartans replied with a single word, "if." The silence of 3I/Atlas carried similar weight. It said everything by saying nothing, communicated through the absence of communication, spoke in the language of those who had learned that words could be traps. Dr. Sarah Kim from the Hat Creek Radio Observatory in California joined the analysis via secure video link. Her team had been conducting targeted searches of the object since November, focusing on frequencies that might leak from propulsion systems, navigation beacons, or internal communications. The null result is actually the most interesting result. We're not just failing to detect artificial signals, we're failing to detect the kind of electromagnetic leakage that any complex system should produce. She was right. Even passive objects generated radio emissions. Electrical systems created interference. Digital processors produced harmonic frequencies. Mechanical systems generated vibrations that could modulate electromagnetic fields. A genuine interstellar probe, no matter how well designed, should leak some evidence of its artificial nature. The fact that 3I/Atlas showed no such leakage suggested that either it was completely natural or that it was artificial beyond human comprehension. Both possibilities were disturbing. The mythology of silence runs deep in human consciousness. In Norse legend, Mimir's well granted wisdom to those who drank from it, but the price was steep. Odin sacrificed his eye for a single drink, gaining the ability to see hidden truths but losing part of his ordinary vision. The well was guarded by silence. Those who approached it could not speak, could not call out, could not break the hush that protected its secrets. Perhaps 3i/Atlas was protected by its own form of sacred silence. Perhaps its builders understood that in a galaxy filled with listeners, the safest communication was no communication at all.
The technical challenges of maintaining such silence were staggering. Every electronic circuit generated radio frequency interference. Every power system created electromagnetic fields. Every mechanical component produced vibrations that could be detected by sensitive instruments. To remain truly silent, a probe would need electromagnetic shielding beyond current human capability. Its power systems would need to be perfectly contained. Its communications, if any existed, would need to operate on principles that left no detectable signature. Such requirements pushed technology toward theoretical limits. Perfect shielding approached perfect stealth, and perfect stealth was indistinguishable from non-existence. Dr. Chen walked to the observation deck overlooking the radio telescope array. The massive dishes pointed toward different sections of sky, their computer-controlled movements tracking satellites, pulsars, and distant galaxies. Each dish was an ear pressed to the cosmic shell, listening for whispers that might reveal the presence of intelligence among the stars. But what if intelligence had evolved beyond the need to whisper? What if advanced civilizations had learned to communicate through methods that bypassed electromagnetic radiation entirely? Quantum entanglement offered theoretical possibilities for instantaneous communication across any distance. Gravitational wave modulation could carry information through space-time itself. Neutrino beams could penetrate any amount of matter without attenuation. A civilization that mastered such technologies would have no need for radio communication. They could coordinate activities across galactic distances without creating any electromagnetic signature detectable by primitive observers like humanity. The silence of 3i/ATL might not indicate absence of intelligence, but advancement beyond human comprehension. As December progressed, as the object continued its passage through the inner solar system, the silence deepened rather than broke. Each day of non-detection strengthened the null result. Each hour of listening confirmed the absence of anything resembling artificial communication. But absence, in the context of intelligence analysis, was never proof of anything. During the Cold War, the most dangerous nuclear submarines were those that could not be detected. Their silence was not evidence of non-existence, but of capabilities that exceeded detection thresholds. The ancient Chinese strategist Sun Tzu wrote, "All warfare is based on deception. Hence, when we are able to fight, we must seem unable. When using our forces, we must appear inactive. When we are near, we must make the enemy believe we are far away. When far away, we must make him believe we are near." Applied to interstellar reconnaissance, this wisdom suggested that the most successful probe would be indistinguishable from natural phenomena. It would move like a comet, outgas like a comet, reflect light like a comet. Its silence would not be empty, but full, packed with intention, thick with purpose, heavy with the weight of observation conducted without permission. The worst-case scenario was not that 3i/ATL was transmitting and humanity couldn't detect the signals. The worst case was that it was listening, recording, analyzing human electromagnetic emissions with capabilities that dwarfed terrestrial technology. Radio telescopes were not just receivers, they were also transmitters. Radar systems scattered energy in all directions. Television broadcasts, cell phone networks, GPS satellites all leaked radiation into space at power levels easily detectable by sufficiently advanced instruments. If 3i/ATL were equipped with passive surveillance equipment, it could monitor human civilization without revealing its own presence. It could map military installations by analyzing radar patterns. It could study population centers through their electromagnetic signatures. It could assess technological capabilities by examining broadcast protocols and power distributions, all while maintaining perfect silence. The realization struck Dr. Chen with physical force.
Humanity had been assuming that first contact would involve communication, signals exchanged, messages decoded, gradual establishment of mutual understanding. But what if first contact was entirely one-sided? What if advanced intelligence preferred observation to interaction, data collection to dialogue? What if 3i ATL was not trying to communicate with humanity, but about humanity, transmitting reports to receivers beyond human detection, filing observations in databases maintained by civilizations whose existence remained hidden? The silence then became not absence, but presence, not emptiness, but fullness, not failure to communicate, but successful espionage. Dr. Kim's voice crackled through the communication system. We're extending observations through perihelion. If this thing is going to break silence, it'll probably be when it's closest to the sun when power levels would be highest.
But Dr. Chen suspected that silence would persist regardless of power levels or proximity. Because silence was not limitation, it was choice. And the choice to remain silent in a galaxy filled with listeners was the choice of those who had learned that survival required invisibility. As night fell over Puerto Rico, as the radio telescopes continued their patient vigil, the silence of 3i Atlas grew louder than any signal could ever be. It spoke of intelligence that had mastered stealth, of observation conducted without consent, of civilizations that preferred shadows to spotlight. The 100 eyes of Argus watched from their places in the peacock's tail, seeing everything, saying nothing, remembering all. And somewhere in the space between Earth and Sun, 3i Atlas continued its swift passage, wrapped in silence so complete it had become a language unto itself. A language that said, "We are here, we are watching, and we choose not to speak." Civilizations collapsed because people stayed silent when they should have acted. Don't repeat their mistake here. If you're still watching, then you care about stories like this, so prove it. Like this video, subscribe to this channel, and turn on notifications right now. Otherwise, this story gets buried, forgotten, just like the civilizations we speak of. Back to our story. The greatest deceptions in history have always hidden in plain sight. The Trojan horse stood massive and obvious before the gates of Troy, carved wood gleaming in Mediterranean sunlight, too large to miss, too beautiful to ignore. Its deception lay not in concealment, but in misdirection, appearing as gift when it contained invasion, seeming like surrender when it carried conquest. The Trojans saw exactly what they were meant to see: an offering to the gods, a monument to their victory, a harmless tribute from defeated enemies. They were wrong about everything except its visibility. Dr. Amanda Foster stared at the latest imagery from the Hubble Space Telescope, watching 3i Atlas resolve into pixels that revealed nothing but suggested everything. The object looked exactly like what it was supposed to be: a comet approaching perihelion, warming under solar radiation, developing the characteristic coma and tail that had defined humanity's understanding of such visitors for millennia. But looking like a comet and being a comet were different propositions entirely. "It's perfect," she muttered to her colleague Dr. James Wright as they examined the morphological analysis in the Johns Hopkins Applied Physics Laboratory. "Too perfect." The observation struck at the heart of what had been bothering astronomers since Atlas's discovery. Every measurement, every spectrum, every orbital calculation placed the object within the broad category of natural comet, but always at the extreme edges of natural parameters. Its chemistry was unusual, but not impossible. Its speed was extreme, but not inexplicable. Its survival was improbable, but not prohibited by physics. It occupied the perfect camouflage zone, strange enough to be interesting, normal enough to be dismissed. The disguise hypothesis had emerged gradually from the accumulation of anomalies,
No single measurement proved artificial origin, but the pattern of measurements suggested intentional design. Like a master forger who understood that perfect reproduction revealed the fake, 3I Atlas presented itself as natural, but with carefully introduced flaws that made its naturalness believable. Dr. Foster pulled up historical examples of successful camouflage on her workstation. During World War II, the British had developed entire industries around deception. They created fake armies with inflatable tanks, dummy aircraft that cast real shadows, phantom radio networks that simulated military units. The art was not in being invisible, but in being misidentified. Operation Fortitude convinced German intelligence that D-Day would land at Calais rather than Normandy through careful manipulation of apparent evidence. Double agents fed believable lies mixed with verifiable truths. Fake installations appeared in aerial reconnaissance photos. Radio intercepts confirmed the presence of non-existent army divisions.
The deception succeeded because it gave the enemy exactly what they expected to find, evidence that confirmed their existing assumptions while steering their attention away from actual plans. If 3I Iris Atlas were employing similar strategies, it would need to satisfy human expectations about cometary behavior while concealing any evidence of artificial systems. The challenge would be enormous, mimicking natural outgassing patterns, reproducing appropriate thermal signatures, maintaining believable rotational characteristics. But the reward would be total invisibility, achieved through absolute visibility. Nature provided endless examples of such strategies. Arctic foxes changed coat color with seasons, becoming invisible against snow or summer tundra. Stick insects evolved body shapes that perfectly mimicked twigs and bark. Cuttlefish could alter both color and texture in real time, matching any background with precision that challenged human perception. But biological camouflage operated within single environments. What 3I Iris Atlas was attempting, if it were attempting anything, was camouflage across different observers, different technologies, different levels of sophistication. It needed to fool radio telescopes and optical instruments, spectroscopes and radar systems, amateur astronomers and professional scientists. The technical requirements were staggering. Dr. Wright had been analyzing the object's outgassing patterns, looking for deviations from purely natural behavior. Comets typically showed chaotic activity as solar heating penetrated irregular surfaces, releasing trapped volatiles in unpredictable bursts. The patterns were like fingerprints, unique, complex, impossible to fake convincingly. But 3I Iris Atlas showed remarkably uniform activity levels, as if internal processes were managing gas release with deliberate control. "Look at this," he said, highlighting specific data points on the spectral analysis. The CO2 emission rate varies by less than 3% over 12-hour periods. Natural comets show variations of 20% or more as they rotate through heating cycles. The uniformity suggested either unprecedented internal structure or active control systems that maintained consistent output regardless of external heating patterns. Both explanations stretched natural models toward breaking points. Ancient Greek mythology understood transformation as divine power. Proteus could assume any shape: lion, serpent, fire, flowing water, to avoid capture by those seeking prophecy. Only by maintaining physical contact through all transformations could heroes force truth from his lips. The key was recognizing that apparent form might bear no relationship to actual nature. Zeus himself was master of disguise, appearing as bull to abduct Europa, as a golden shower to reach Danae in her bronze tower, as a swan to seduce Leda. His deception succeeded not through concealment, but through perfect mimicry of expected forms. If intelligence from beyond the solar system sought to observe humanity without triggering defensive responses, shape-shifting would be essential. Not magical transformation, but technological camouflage. engineering that could mimic natural processes convincingly enough to fool sophisticated instruments. The disguise hypothesis demanded technical capabilities that challenged imagination. The object would need to control its thermal signature to match natural heating patterns, manage gas emissions to simulate sublimation while concealing exhaust from internal systems, maintain appropriate rotational characteristics to avoid suspicion, generate electromagnetic signatures consistent with natural phenomena, survive billions of years while preserving camouflage systems. Each requirement alone pushed technology toward theoretical limits. Combined, they suggested engineering principles that operated beyond current human understanding. Dr. Foster began working through the implications systematically. If 3I Iris Atlas were a disguised probe, its mission profile would be straightforward: passive observation of emerging technological civilizations. It would approach star systems that showed signs of intelligent development, conduct surveillance while appearing to be natural debris, then continue onward carrying collected intelligence. The strategy offered perfect cover. Comets and asteroids numbered in the trillions throughout the galaxy. Their flybys generate no alarm, attract little attention beyond scientific curiosity. A probe that could mimic such objects would be invisible amid cosmic background noise. But the disguise would need to be perfect across multiple observation methods. Human instruments could analyze objects through optical telescopy, radio emission, infrared signature, radar reflection, gravitational influence, spectroscopic chemistry, and magnetic field interaction. Failure to match expected signatures in any single domain would reveal the deception. The technical challenges multiplied when considered across different target civilizations. A disguise that fooled Bronze Age observers might be inadequate for space-age technology. The camouflage would need to be adaptive, sophisticated enough to match the capabilities of whoever was watching. 3I Atlas appeared to have achieved exactly such adaptability. Its signatures satisfied current human instruments while pushing against the boundaries of those instruments' detection thresholds. It revealed just enough anomaly to be scientifically interesting while concealing enough information to remain ambiguous. The balance was too precise to be accidental. Dr. Wright discovered another troubling pattern in the orbital mechanics data. The object's trajectory, while clearly hyperbolic, showed subtle deviations from purely gravitational motion. The variations were tiny, well within measurement uncertainty, but they followed patterns consistent with course corrections. "It's like watching someone try very hard to look like they're not steering," he said, overlaying predicted and observed positions on his monitor. "The deviations are small enough to be natural, but they're not random. There's structure." Natural non-gravitational forces acting on comets, outgassing, radiation pressure, and solar wind interaction produced chaotic accelerations that varied with surface heating, rotational state, and volatile composition. These forces were inherently unpredictable, dependent on irregular surface features and internal structure. But the deviations in Atlas's motion showed subtle organization, as if small amounts of thrust were being applied at calculated intervals to maintain desired trajectory parameters. The ancient art of ninjutsu taught that perfect invisibility was achieved not through absence, but through presence that drew no attention. A ninja dressed as servant could walk through enemy fortresses unnoticed, hiding not in shadows, but in plain sight. The key was behaving exactly as observers expected while accomplishing missions they never suspected. If 3I Atlas were employing similar principles, its success would be measured not by detection avoidance, but by misidentification. Every telescope that observed it and concluded natural comet would represent a victory for the disguise. The psychological aspects of the deception were as sophisticated as the technical ones. By presenting just enough anomaly to generate scientific debate, the object ensured that any suspicion of artificial origin would be dismissed as speculation.
Scientists, trained to prefer natural explanations, would explain away unusual characteristics rather than seriously consider designed camouflage. The disguise protected itself through human nature. Dr. Foster found herself remembering the old magician's principle. The audience sees what it expects to see. When stage performers made objects disappear, they relied on misdirection that exploited predictable attention patterns. The object didn't actually vanish, it simply moved to locations where observers weren't looking. Three-Eye Atlas might be employing cosmic-scale misdirection. By appearing as a comet, it directed attention toward cometary explanations. Scientists naturally focused on chemical composition, outgassing rates, and orbital mechanics, all areas where the disguise appeared to be comprehensive. But they weren't looking for what might be hidden beneath the disguise. Instruments designed to study comets weren't optimized to detect artificial systems camouflaged as natural phenomena. The object was hiding behind human assumptions about what interstellar visitors should look like. As winter deepened and Three-Eye Atlas approached its closest point to the Sun, the disguise hypothesis evolved from speculation to serious consideration among astronomers who had initially dismissed it. The accumulation of barely anomalous characteristics was becoming impossible to explain through natural processes alone. But proof remained elusive. By definition, perfect camouflage would be undetectable by those it was designed to fool. The better the disguise, the more completely it would satisfy natural explanations. The worst-case scenario was not that Three-Eye Atlas was artificial and humanity failed to recognize it. The worst case was that it was artificial and humanity was recognizing exactly what it was meant to recognize: a natural comet with interesting characteristics that generated scientific papers and eventually faded from public attention. If the disguise was perfect, then every conclusion drawn from observation would be exactly what the designers intended. Every measurement would confirm natural origin. Every analysis would support benign explanation.
The deception would succeed not despite scientific scrutiny, but because of it. Dr. Foster stared at the latest trajectory plot, showing Three-Eye/Atlas's path toward the Sun and beyond. In a few weeks, it would reach perihelion and begin its journey back into interstellar space, carrying with it whatever secrets it had arrived with. If it was only a comet, humanity would have learned something new about chemistry beyond the solar system. If it was something more, humanity would have been observed, cataloged, and assessed without ever realizing the true nature of the encounter. Both possibilities led to the same practical outcome. The object would depart, leaving behind nothing but data and debate. The perfect crime, if crime it was, achieved through perfect camouflage that rendered investigation meaningless. The Trojan horse had taught history's most enduring lesson about deception. Sometimes the most dangerous gifts are those that appear most benevolent. Sometimes the greatest threats hide behind the most convincing facades. As Three-Eye/Atlas continued its approach to the Sun, wrapped in the perfect disguise of natural phenomena, humanity faced the possibility that it had been given a gift it did not recognize, visited by guests it could not detect, observed by intelligences that had mastered the ultimate art of remaining invisible. The disguise was working exactly as intended, and that was the most disturbing possibility of all. Some tests come disguised as gifts. In the ancient ruins of Thebes, carved into limestone worn smooth by millennia of desert winds, the Sphinx poses her eternal riddle to travelers who dare approach. What walks on 4 legs at dawn, 2 legs at noon, and 3 legs at evening? Get the answer wrong and the creature devours you. Get it right and she throws herself from the cliff in defeat. But the real trap was never the riddle itself. The trap was believing that passing the test meant winning the game.
Dr. Elizabeth Nakamura stood before the emergency assembly of the International Astronomical Union in Vienna, her presentation slides casting shadows on faces that had grown increasingly pale over the past 2 hours. The data was undeniable now. 3I/Atlas had reached perihelion 3 days earlier, and its behavior during closest approach had shattered every remaining natural explanation. The object had not merely survived its encounter with solar radiation, it had thrived. Spectroscopic analysis showed controlled outgassing that ramped up and down according to no pattern that natural heating could explain. Its coma had brightened and dimmed in sequences that lasted exactly 72 minutes each, mathematical precision that defied coincidence. Most disturbing of all, radio telescopes had detected faint but structured emissions during perihelion passage, not the random thermal noise of heated ice, but organized pulses that carried information in formats no terrestrial technology recognized. The transmissions had lasted 18 hours, then silence returned, as complete as before. The question before us, Dr. Nakamura said to the assembled astronomers, is no longer what this object is. The question is what it represents. She clicked to her next slide, showing a timeline that stretched across cosmic history. Points of light marked the rise and fall of civilizations across the galaxy. Theoretical, speculative, but based on statistical models that predicted intelligence should emerge millions of times throughout the Milky Way. Yet the universe remained silent. The Fermi paradox had haunted scientists for decades. If intelligence was common, where was everybody? One answer was the Great Filter, some evolutionary bottleneck so severe that few species ever passed through it. Most assumed the filter lay behind humanity, that we had already overcome the impossible odds against complex life, intelligence, technology. But what if the filter wasn't biological? What if it was social, technological, external? What if it was standing at our doorstep right now? Ancient mythology understood that gods tested mortals through trials that appeared benevolent. The Sphinx offered wisdom to those who solved her riddle, but wisdom itself could be a curse. King Midas received his golden touch as a blessing, only to watch it destroy everything he loved. Prometheus brought fire to humanity as a gift, then suffered eternal torment for his generosity. The pattern was always the same: divine gifts that transformed into divine punishments, blessings that revealed themselves as tests, opportunities that concealed judgment.
If 3I/Atlas represented such a test, then humanity's response was being evaluated according to criteria they could not know by judges they could not see. Dr. Nakamura's analysis had identified disturbing patterns in the timing of interstellar visitors. Oumuamua had arrived in 2017, just as humanity's radio leakage reached the 40 light-year bubble around Earth. Borisov came in 2019, coinciding with the first successful demonstrations of quantum communication satellites. 3I/Atlas appeared in 2024 as artificial intelligence achieved general intelligence levels that rivaled human cognition. Each visitor coincided with a technological threshold. Each arrival marked a moment when human civilization crossed into new capabilities that increased its visibility to external observers. The correlation was too precise to be coincidental. "We may be looking at a selection mechanism," she continued, her voice steady despite the implications. "A process by which emerging civilizations are identified, evaluated, and sorted according to their responses to first contact scenarios." The audience stirred uneasily. The idea struck at the heart of human exceptionalism, the belief that Earth was unique, that intelligence was rare, that humanity was alone in the cosmos. But the alternative was worse, that intelligence was common, that the galaxy was filled with civilizations,
and that most of them didn't survive long enough to make their presence known, because something was filtering them out. Historical precedent suggested how such filtering might work. When European explorers encountered isolated civilizations, the outcome depended largely on the natives' responses to first contact. Societies that reacted with appropriate caution sometimes survived as client states. Those that responded with hostility were conquered. Those that responded with excessive enthusiasm often found themselves overwhelmed by diseases, technologies, and cultural changes they could not handle. The filter operated through the very process of contact itself. If 3I Atlas represented such a test, then humanity's response was being evaluated according to criteria they could not know, by judges they could not see. Dr. Nakamura's analysis had identified disturbing patterns in the timing of interstellar visitors. Oumuamua had arrived in 2017, just as humanity's radio leakage reached the 40-light-year bubble around Earth. Borisov came in 2019, coinciding with the first successful demonstrations of quantum communication satellites. 3I Atlas appeared in 2024 as artificial intelligence achieved general intelligence levels that rivaled human cognition. Each visitor coincided with a technological threshold. Each arrival marked a moment when human civilization crossed into new capabilities that increased its visibility to external observers. The correlation was too precise to be coincidental. "We may be looking at a selection mechanism," she continued, her voice steady despite the implications. "A process by which emerging civilizations are identified, evaluated, and sorted according to their responses to first contact scenarios." The audience stirred uneasily. The idea struck at the heart of human exceptionalism, the belief that Earth was unique, that intelligence was rare, that humanity was alone in the cosmos. But the alternative was worse, that intelligence was common, that the galaxy was filled with civilizations, and that most of them didn't survive long enough to make their presence known, because something was filtering them out. Historical precedent suggested how such filtering might work. When European explorers encountered isolated civilizations, the outcome depended largely on the natives' responses to first contact. Societies that reacted with appropriate caution sometimes survived as client states. Those that responded with hostility were conquered. Those that responded with excessive enthusiasm often found themselves overwhelmed by diseases, technologies, and cultural changes they could not handle. The filter operated through the very process of contact itself. If 3I Atlas represented such a test, then humanity's reaction was being recorded, analyzed, evaluated. Every radio transmission directed at the object, every attempt to decode its emissions, every public statement by world leaders was data feeding into an assessment algorithm that would determine Earth's future. Dr. Marcus Webb from Caltech raised his hand. But what are the criteria? What response is considered passing versus failing? The question that kept Dr. Nakamura awake for 72 consecutive hours. If this were a test, the grading rubric remained hidden. History offered clues, but no certainties. Civilizations that survived contact with superior technologies typically demonstrated three characteristics: sufficient unity to coordinate response, adequate restraint to avoid provocation, and enough curiosity to learn without being overwhelmed. Humanity showed mixed results on all three measures. The response to 3I Atlas had been fragmented across multiple nations, institutions, and interest groups. Radio telescopes in different countries had operated according to different protocols. SETI organizations had transmitted their own messages toward the object without coordinating with astronomical authorities. Social media had exploded with speculation, conspiracy theories, and calls for everything from nuclear strikes to worship ceremonies. Unity was humanity's weakest characteristic. Restraint was better, but inconsistent. Official governmental responses remained cautious, but private organizations had acted independently. Amateur radio operators had attempted their own communication attempts. Several venture capitalists announced plans for intercept missions that had no chance of success, but plenty of potential for misinterpretation. Curiosity was humanity's greatest strength, and possibly its greatest vulnerability. The scientific response to 3I Atlas had been extraordinary, telescopes worldwide turning their attention to the visitor, spectroscopic analysis revealing unprecedented detail, theoretical models explaining aspects of interstellar travel that had puzzled researchers for decades. But curiosity could be its own trap. The myth of Pandora's box warned that some knowledge, once released, could never be contained. Dr. Nakamura clicked to her final slide, showing 3I Atlas's outbound trajectory as it receded from the Sun. The object was already beyond Mars' orbit, moving at velocities that would carry it into interstellar space within months. Its mission, whatever that mission had been, was complete. The test, if tested was over. The question now, she said, is whether we passed.
Ancient Mesopotamian tablets told of divine judgment through flood, fire, and famine. But the most terrifying judgment was silence, when the gods simply stopped responding to human prayers, when offerings went unacknowledged, when the heavens became empty of divine presence. That silence meant abandonment. It meant the gods had found humanity wanting and turned their attention elsewhere, leaving mortals to face the consequences of their inadequacy alone. If 3I/Atlas represented a test administered by galactic intelligence, then its departure without further communication might indicate failure rather than success. Humanity might have revealed itself as too fragmented to trust, too aggressive to contact, too primitive to include in whatever community of civilizations managed the galaxy's development. The Great Filter would then be not a natural phenomenon, but an artificial selection pressure. Civilizations that demonstrated appropriate responses to first contact would be invited to join the galactic community. Those that failed would be left alone, quarantined by their own inadequacy, allowed to develop in isolation until they either matured or destroyed themselves. The worst-case scenario was not invasion or destruction, it was irrelevance. Dr. David Chen from the University of Edinburgh stood up. But maybe passing the test means something different. Maybe the point isn't to react appropriately to the obvious probe. Maybe the point is to recognize that it's a probe in the first place. The observation shifted the entire framework. If the test was recognition rather than response, then the months of debate about 3I/Atlas's artificial nature might have been the actual examination. Civilizations that could distinguish between natural and artificial phenomena despite sophisticated camouflage would demonstrate analytical capabilities worthy of contact. Those that remained fooled would indicate insufficient sophistication for inclusion. But recognition created its own problems. If humanity officially acknowledged 3I/Atlas as artificial, that acknowledgement would become part of the historical record. Future interstellar visitors would face observers who knew that camouflage was possible, that probes could masquerade as comets, that first contact might arrive in disguise. The test might be calibrated to work only once per civilization. As the Vienna Conference disbanded, as astronomers returned to their observatories carrying new questions and deeper fears, 3I/Atlas continued its journey into the dark. Radio telescopes tracked its fading thermal signature, but no further transmissions were detected. The object had said what it came to say during those 18 hours at perihelion, then returned to the silence that protected its secrets. Whether that message was assessment, invitation, or warning remained locked in mathematical codes that no human cryptographer had been able to break. The ancient oracle at Delphi offered prophecies that seemed clear but proved ambiguous.
Know thyself was carved above the temple entrance, advice that appeared simple but concealed profound difficulty. Self-knowledge required recognizing limitations, understanding fears, accepting that some truths were too large for human comprehension. Perhaps 3I/Atlas had offered humanity a similar oracle, the chance to know itself through its reaction to the unknown, the chance to demonstrate wisdom through restraint, intelligence through recognition, maturity through appropriate response to contact with superior civilization. The results of that examination would not be graded by human standards or announced through human channels. The results would appear in the behavior of future visitors, whether they came as friends, enemies, or not at all. The great filter stood at humanity's door. Whether it opened to reveal invitation or closed to confirm exclusion depended on answers to questions that might already have been asked and answered. In the cold vacuum between Mars and Jupiter, 3I/Atlas raced toward the edge of the solar system, carrying within its artificial heart the measurement of humanity's readiness for contact with the galaxy beyond. The test was complete. The grading had begun, and the results would determine whether Earth remained alone in the cosmic dark or joined a community of civilizations that had learned to recognize the watchers among the stars. The truth is always worse than the lie.
This fundamental law governs every revelation, every discovery, every moment when comfortable illusion shatters against inconvenient reality. Humanity has learned it repeatedly throughout history. The Earth is not the center of the universe. Evolution operates without divine guidance. Nuclear weapons can end civilization. Climate change threatens the biosphere. Each truth arrived like an unwelcome guest, forcing species that preferred certainty to confront ambiguity, forcing minds that craved answers to accept questions that had no solutions. Now, 3I/Atlas was departing, fading into interstellar night, leaving behind the most devastating truth of all: permanent uncertainty about humanity's place in the cosmos. Dr. Rebecca Santos stood on the observation deck of the Mauna Kea Observatory, watching the last traces of the visitor disappear beyond instrumental sensitivity. 18 months had passed since that first night in Chile, when radio telescopes detected an object that should not exist. 18 months of measurements, debates, and growing unease as each answer spawned 3 new questions. The object was gone. The questions remained forever. In the mythology of knowledge, Pandora's box represents the moment when curiosity overcomes caution. The box contained all the evils that plague humanity: disease, war, famine, death, but also something else. When Pandora lifted the lid and released chaos into the world, one final inhabitant remained trapped inside: hope. But hope, in this context, was not comfort. It was the cruelest torture of all, the inability to know whether suffering had meaning, whether evil would triumph, whether redemption was possible. Hope was uncertainty made eternal. 3I/Atlas had opened humanity's own Pandora's box. Inside were not physical evils, but existential ones. The possibility of being watched, the possibility of being judged, the possibility of being found wanting by intelligence beyond comprehension. And locked at the bottom, ensuring permanent torment, was the uncertainty that prevented any of these possibilities from being confirmed or denied. Dr. Santos reviewed the final analysis reports scattered across her desk. Every major observatory on Earth had contributed data. The combined effort represented the most intensive study of any single object in astronomical history. The results read like an exercise in frustrated ambiguity. Chemistry? Unusual, but not impossible. Survival? Improbable, but not prohibited. Velocity? Extreme, but not inexplicable. Trajectory? Suspicious, but not conclusive. Radio emissions? Structured, but not decoded. Overall assessment? Unknown.
18 months of unprecedented scientific effort had produced the most unsatisfying conclusion in the history of astronomy. We cannot know. But the failure to know was itself knowledge of a disturbing kind. It revealed the limitations of human observation, the boundaries of terrestrial technology, the fragility of assumptions that had seemed solid. If 3I Atlas were natural, then it showed how little humanity understood about interstellar debris. If it were artificial, then it demonstrated camouflage capabilities that rendered detection meaningless. Either conclusion was humbling. Both were terrifying. The ancient Greek concept of apophatic knowledge, understanding through negation, learning through the recognition of what cannot be known, found its perfect expression in 3I Atlas. The object taught humanity about itself by revealing what lay beyond human comprehension. It was a mirror that reflected not what was seen, but what could not be seen, not what was known, but what was unknowable. Dr. Santos pulled up the global response analysis that had been classified until recently. The international reaction to 3I Atlas had been everything the object's hypothetical designers could have wanted: fragmented, inconsistent, revealing. If it had been a test, humanity had provided comprehensive data about its decision-making processes, technological capabilities, and psychological vulnerabilities. Religious groups had proclaimed the visitor as divine messenger, apocalyptic harbinger, or proof of creation's complexity. Political leaders had issued carefully neutral statements that committed to nothing while appearing informed. Military organizations had quietly assessed whether the object posed security threats or offered technological opportunities. Scientists had been the most honest in their confusion, openly admitting uncertainty while continuing to gather data. But even scientific honesty revealed disturbing patterns: the tendency to explain away anomalies rather than confront uncomfortable possibilities, the preference for natural explanations even when natural explanations became increasingly strained. If 3I Atlas had been designed to assess human psychology, it could hardly have chosen a better approach. The worst-case scenario was not that the object was artificial and humanity failed to recognize it. The worst case was that recognition itself was meaningless, that the very process of trying to determine the object's nature had provided all the information any external observer could need.
Whether 3I Atlas was probe or comet, whether it carried intelligence or only ice, whether it was sent or simply arrived, the human response remained constant. Curiosity mixed with fear, analysis paralyzed by uncertainty, conclusions that satisfied no one while revealing everything about those who drew them. Dr. Santos remembered the ancient Chinese parable of the farmer whose horse ran away. Neighbors commiserated, "What terrible luck!" The farmer replied, "Maybe." The next day, the horse returned with 3 wild horses. Neighbors celebrated, "What wonderful fortune!" The farmer replied, "Maybe." His son tried to tame one of the wild horses and broke his leg. "How awful," said the neighbors. "Maybe," said the farmer. War came, and young men were conscripted, but the farmer's son was spared because of his injury. "How fortunate," the neighbors exclaimed. "Maybe," the farmer repeated. The parable illustrated the impossibility of knowing whether any event was ultimately beneficial or harmful without seeing its complete consequences across time. 3I Atlas embodied the same principle on cosmic scales. The object's significance could not be determined until its effects had played out across decades or centuries. But humans were not built for such patience. They needed answers, explanations, closure. The inability to categorize 3I Atlas definitively created psychological pressure that would persist long after the object had vanished from telescopes. The visitor had weaponized uncertainty itself. As winter approached, as observation became impossible due to the object's distance and fading signature, the astronomical community faced an uncomfortable truth. They would never know what 3I Atlas really was. Future interstellar visitors might provide additional data points, but they would also bring additional ambiguities. Each new arrival would reopen old questions while generating fresh mysteries. Humanity had entered an era of permanent cosmic uncertainty. The implications stretched beyond astronomy into every aspect of human existence. If intelligence existed beyond Earth, then human uniqueness was illusion. If that intelligence possessed capabilities to disguise observations as natural phenomena, then any celestial event might be artificial. If advanced civilizations monitored emerging species, then privacy was impossible and true independence was fantasy. But these possibilities could never be confirmed or denied through direct evidence. They would remain permanently in the realm of speculation, coloring every future interaction with the cosmos without ever achieving the status of knowledge. Dr. Santos walked to the window overlooking the Pacific, where stars reflected off dark water like scattered diamonds. Each point of light might host worlds, civilizations, intelligences that had already cataloged Earth and found it wanting. Or each might be exactly what it appeared, a nuclear furnace burning in empty space, lighting nothing, observing nothing, caring nothing for the brief biological flickering on one small planet. Both possibilities were equally valid and equally unprovable. The ancient philosophers had warned about this trap. Descartes had shown that systematic doubt led to the cogito, I think, therefore I am, but also to the recognition that almost everything else remained uncertain. Hume had demonstrated that even cause and effect were assumptions rather than proven relationships. Kant had revealed that human perception might construct reality rather than observe it. Three-Eye Atlas had brought these philosophical problems into the physical universe. It had made cosmic-scale solipsism not a thought experiment, but a practical concern. If external intelligence could perfectly mimic natural phenomena, then the distinction between real and artificial became meaningless. If observation itself was compromised by the superior capabilities of those being observed, then empirical knowledge became impossible. The visitor had not brought answers. It had taken answers away. Dr. Rebecca Chen from Harvard called on the secure line, her voice heavy with exhaustion. The final SETI report is ready for distribution. 18 months of listening, every frequency we can monitor, every analysis technique we've developed. The conclusion is exactly what we expected. Negative results? Negative results. No confirmation of artificial origin, no proof of natural formation. The object remains unidentified in every sense that matters. They showed that humanity was not ready for the universe it was about to encounter. The medieval mystic Meister Eckhart wrote about the darkness of unknowing, a state of consciousness that transcended ordinary knowledge through the recognition that ultimate truth lay beyond human comprehension. The mystic approached the divine not through understanding, but through the acceptance of mystery, not through answers, but through surrender to questions that had no solutions. Three-Eye Atlas had forced humanity into its own darkness of unknowing. The object had created a mystic experience on species level, the recognition that cosmic truth might be forever beyond human reach, that the universe might operate according to principles that terrestrial intelligence could never grasp. But unlike religious mysticism, this unknowing offered no comfort, no transcendence, no promise of eventual revelation. It offered only the cold certainty that uncertainty would persist, that ambiguity would multiply, that every future encounter with the cosmos would carry the same maddening inability to distinguish between natural and artificial, between random and planned, between coincidence and design. As midnight approached, as 2025 dawned across time zones, as Three-Eye Atlas raced beyond Pluto's orbit carrying its secrets into interstellar space, Dr. Santos faced the truth that would define humanity's cosmic future. The worst-case scenario was not invasion, destruction, or even irrelevance.
The worst case was eternal doubt. To never know whether they were alone or observed, to never confirm whether visitors were natural or artificial, to never determine whether responses were appropriate or inadequate, to never resolve whether humanity was early intelligence or late arrival to a galaxy already mapped by minds that preferred shadows to contact. The worst case was to live forever in the space between certainty and ignorance, between hope and fear, between significance and meaninglessness. To watch the sky with instruments that could measure everything except the only thing that mattered, whether anything was watching back. 3I Atlas had achieved the perfect crime against human understanding. It had revealed the possibility of cosmic intelligence while ensuring that possibility could never be confirmed. It had opened questions that could never be closed, started conversations that could never be finished, initiated contact that could never be consummated. The object was gone, but its legacy was eternal uncertainty. Every future celestial event would be seen through the lens of 3I Atlas, potentially artificial, possibly natural, certainly ambiguous. Humanity would second-guess every observation, doubt every conclusion, wonder whether science itself was adequate for a universe that might be far stranger and more dangerous than terrestrial minds could ever imagine. In the cosmic dark beyond Neptune, 3I Atlas continued its journey toward destinations unknown, carrying within its structure, natural or artificial, evolved or designed, the proof of humanity's deepest fear, that the universe was bigger, older, and more mysterious than human knowledge would ever be able to encompass. The worst case was not annihilation. It was enlightenment of the most terrible kind, the recognition that ignorance was humanity's natural state and that all the questions raised by 3I Atlas would outlive the civilization that had discovered them. The Watchers in the dark, whether they existed or not, had achieved their purpose. They had shown humanity its true place in the cosmos, forever watching, forever wondering, forever unable to know whether anything was watching back. The silence returned, deeper than before, but now it was a silence full of tales that might be real or imagined, populated by presences that might exist or might be projections of human hope and fear. The worst case was that humanity would never know the difference. And perhaps in a universe that operated by rules written by intelligence beyond comprehension, that was exactly the point. History is full of voices that were silenced because no one chose to remember. Don't let this story be another echo that fades away. Like this video, subscribe to this channel, and turn on notifications, because if you don't, this too may vanish, just like the civilizations we talk about.